Good morning, everyone. Good morning. Hope all is well. Hope everybody's all right. Let's see, is everybody in here yet? Okay, looks like got one trying to connect. All right. So before we get rolling into anything, anybody have any general questions or concerns? I know.
No,
Mhm.
so the graphing thing's been kicking my butt.
Mhm.
I'm just giving you a heads up. So I want to talk to you or set up a time where we can get together and go over some of that stuff.
Okay. Okay. Cool. I know you had sent me some questions. Were they on graphing? Was that what that was about? I
Yeah,
didn't get a chance to look at it. So let's see. I'm trying to look and see where we are.
we're
This
about a
is.
chapter past that, I think.
Say that again now.
So I think we're about a chapter past the graphing stuff of what I was having problems with.
Okay. Okay. Hold on one second. All right. So, right, because we did 10. We're done with 10. We'll do it at 4. We need to do one more section out of chapter 4, I believe. No, we didn't do functions, did we? This class. That wasn't the last section. What was the last section that we knocked out in this class? Was it functions?
No, it was slopes.
Okay.
Yeah.
Okay. Cool. Thank you. Thank you. Try to make sure I go to the right place for you guys. Okay. So now, Mr. Tucker, what about graphing? Did you want to look at a few before we do that?
No, I don't want to go through them right now because
Okay.
but I do want to set up a time with you
Okay.
where or we can do it after class if you
Okay.
got.
Yeah. Yeah. Okay. We're talking. So, so we need to go to functions. What do Hold on one second. Before you start copying that, give me one more second. Just trying to get stuff set up so I'll get my flow once we go start rolling. Come on. Yep. All right, we good to go. All right, so let's start right there. This is section 4.4 for us. Talking about 4.4, and it is functions. And we're gonna start that definition of a function, or start talking about functions with the definition of a relation. And a relation is just any set of ordered pairs. So we go back to your graph. Remember, we had our ordered pairs set up as XY. So any set of ordered pairs is considered a relation. So in this case, is this example 1, 2, 3, 4, 5, 6 are your ordered pairs in this relation. Now your domain is the set of all of the first components of the ordered pairs. So in this case, 1, 3, and 5.
So that would be all the X's.
Yep. Everybody first done with the first one. Okay, so your range is a set of all of your second components of the order pairs. And that'll be all your Y's. All right, scrolling up. Done with domain. So here we just have a clean comparison between domain and range. So domain is your first component, range is second component, just like we mentioned. Domain your X variables, excuse me, range your Y variables. Domain is considered your input, range is considered your output. So remember, we will plug in X values, get out the Y values. Domain is your independent variable, while your range is your dependent.
Mr. Tucker, can you please go back up for a second?
No, we don't do that around here. I'm not just messing with you.
Thank you.
Okay. We got one more characteristic after that, so I'll scroll up in a second.
Okay, I'm good. Thank you.
And then your domain is also your horizontal axis, which your X is once again, and your range will be your vertical axis. So even if you're using different letters other than X and Y, these characteristics hold true. So that's why I gave you all of the characteristics of your domain versus your range. Mhm.
What's the difference between, what do you mean when you say independent variable and dependent variable? What is it dependent on?
The range depends on the domain. In other words, your Y depends on your X. So when you go into other applications, that's more so extending beyond this class. I'm just giving it to you just because that is a term that's used for it. But if you ever see that terminology, that means there's an application involved wherein certain things depend. In other words, in statistics, if you comparing when you swing the golf club, how fast you swing it to how far the distance travels. So that means distance travel would be Y. You swinging the golf club would be X. And so how far the ball travels depends on how fast you swung the golf club.
I got you.
You know what I'm saying? So yeah. So that's just the application part of it.
Good example too. I get that was awesome.
Thank you, sir. Thank you. Can we scroll up? Can we scroll up? All right, so we're looking at the actual definition of a function. Of course, if I scroll up too far, let me know. But a definition of a function is is a relation. Going back to relation, is a relation. In other words, a set of ordered pairs in which the elements from the domain corresponds to exactly one element in the range. Don't copy this red circle down there. That's a note for myself. Trying to see if you guys gonna see a problem like this. Okay, we good.
Can you That definition right there is a little too smart for me. Can you put that into layman's terms?
Yeah, we're gonna put some numbers on it,
Okay.
and that'll probably make it, probably easier to digest in this next example. But yep. So can we scroll up some, guys? Let me know. So for example, under this is determine whether each relation is a function. So we have 1, 6. Oh, trying to erase 1, 6, 2, 6, 3, 8, 4, 9. And we want to determine whether this is considered a function or not. So everybody done with black? All right, I'm gonna erase this. So the easiest way to do something like this is to create a mapping of your domain going to your range. So when we look at our domain, we have 1, 2, 3, 4. Those are all of my X values. My range, we have 6, 8, and 9. You don't have to write anything repeated. So if you have a repeated value, you want to write it that one time. Somebody said something. Yep, last part of the black. Yeah. Okay. So we'll pause, make sure everybody's caught up.
There's no number 5?
There's a number, nope, you talking about as far as in a domain?
Yeah.
No, this is all, yep, and I still have my eraser on, nice. All right, so this is it right here. These are only 4 ordered pairs that's in this function. So we got 1, 2, 3, and 4 for our X values. And so, yep, that's all you would include.
And you said you don't have to, if there's one that's repeating, you just got to write it once.
Just write it once. So that's what we did with the 6. We only wrote the 6 one time for the range. So now what you're going to do is analyze each value in your domain and see if it fits the definition of what the function is. I'm going to scroll back down in a second, but I want us to go back here. So a function is a relation in which each element from the domain goes to exactly one element in the range. So you're going to ask yourself, does 1 go to one value, which is 6? The answer is yes. Does 2 go to one value? The answer is yes. Now, it just so happened that 1 and 2 go to the same value, but we're looking at them individually. So 1 goes to one value, 2 goes to one value. 3, does it go to one value? The answer is yes. Does 4 go to one value? The answer is yes. If you can answer yes to all of your elements in your domain, then yes, it is a function.
So
Mhm.
what would be an example of a null?
Man, we gonna get there, man.
Oh, okay.
Yeah.
I'm sorry, man.
No, you good. But that's the next one. I'm gonna show you how it would look if it wasn't one. But is everybody okay with this one though? Like I said, you look at each one of them individually, each element in your domain individually, and ask yourself, is it going to just one value in the range? If each element in your domain is going to just one value in the range, then yes, it is a function. Even if it's repeated over in the range, as long as the ones in the domain are not repeated. Can we scroll up and look at another one? Look at the one that Mr. Tucker is alluding to. All right, let me erase some of this stuff so we can walk through it. So this one, very similar to what we had, just that our stuff is reversed. We have 6, 1, 6, 2, 8, 3, 9, 4. All right. So once again, same thought process. We look at each element in the domain and ask yourself, is it going to just one element in the range? So our domain is 6, 8, 9, range 1, 2, 3, 4. So when you look at 6, does it go to just one value? The answer is no, because it goes to 1 and it goes to 2. So that stops it from being a function. Mhm. Questions on that before we scroll up? All right. So I got two general statements that may help you bring a little more clarity to when you have a function and when not, just based on what we saw in these ordered pairs. There can be a repeated value in the range. Remember, we had 6 that was repeated when it was in Y, but the value cannot repeat when it's in the domain. So if you look at our ordered pairs, go back to the first one, we had a repeated value right here in the range, and it was still a function. But when we had a repeated value here in the domain, it was not a function. So that's what I mean by that. There can be a repeated value in the range, but no value can repeat in the domain. Then the other statement, the range can go to more than one value, but the domain can only go to one value. So it's just a different way of saying it. Like I said, it's just all about how you're interpreting what you see, but just throwing other statements out there. All right. Are we good? Are we good?
No, I need 30 more seconds.
30? You got a whole 30?
Yeah. Thank you.
Not a problem at all. Anybody else? Everybody else? Before we go to the next thing. All right, still in functions. I gotta find the right. Function notation, where my stuff at? All right, cool. So next thing, vertical line test. So we will, if we have a graph, we will be able to use the vertical line test to see if we have any functions. It says a vertical line, any vertical line crosses or touches a graph more than once, it is not a function. So if you have a graph, if a vertical line touches it more than once anywhere, it is not a function. So in the first one, if we look at this circle, when I draw a line through the circle, notice it touches it twice, so it's not a function. We have this line, this linear equation. No matter where I draw my line, it's only going to touch it once. So yes, it is a function. This parabola, no matter where I draw my line, it's only going to touch it once. That's a function. And then in this last graph, last diagram, even though the first 3 lines only touches it once, this fourth line right here touches it 3 times. So once again, that stops it from being a function. All right, questions on the vertical line test. If a vertical line touches a graph more than once, then it is not a function or not a representation of a function. All right.
What line is it supposed to be trying? What line is it supposed to be touching or not touching?
Well, okay, the black, let this black be my graph, this right here. And
Uh-huh.
so if you have any graph, if you draw a vertical line through it, you know, it's not, let's say if you have a graph and it was a square, then if you draw a vertical line through it, that does not represent a function. So they'll give you the graph. And then so you would just draw a vertical line through it. And if anywhere you draw that vertical line, if it touches that graph more than once, then it's not a function.
All right.
All right, last type of thing in this section, talking about function notation. So y is equal to f of x, f parentheses x, the way you say that is f of x. If you have g parentheses x, that's g of x. You know, is that letter of the parentheses and what's in the parentheses? If I have g parentheses t, that's g of t. You know what I mean? That's how you would, you know, say that. So y is equal to f of x. So that means y and f of x are interchangeable. Y and f of x are interchangeable. They can be switched out at any given point in time and they can be unapologetic for it. So if I have y equal to 2x plus 1, the same equation is f of x equal to 2x plus 1. It's just that that's considered function notation. Let's talk about what you got. I see, like you want to ask a question.
I'm just trying to follow along what you're saying. I took a bunch of left turns.
So all we said at this point, is that y and f of x are the same thing. So if I have y equal to 2x, I can rewrite that same equation with f of x equal to 2x. And it means the same thing. So when you see f of x, that's actually y. It's just that f of x, using f of x is actually considered function notation, which is what we're talking about right now. All right. So in mathematics, if you haven't noticed yet, they try to give you as many instructions as possible without giving you words or letters. So that's what function notation is about. So if you see right here, I got find f of 3. They don't necessarily have to write find f of 3, but if you want to know what f of 3 is, that means you're going to take 3 and plug it into your equation of f of x. Now, f of x does have to be defined, so they will give you that. They will tell you what function f of x is or g of x. They'll give you that, but then tell you to find f of, let's say, 3. That means you're going to plug 3 into the function and calculate. So that's what I did right here. F of 3 is going to be 2 times 3 plus 1 because f of x was 2 times x plus 1. So wherever you see x, that's where you'll plug in your number. So 2 times 3 plus 1, that's 6 plus 1, which is 7. So f of 3 is equal to 7. And that's also the ordered pair. Remember, when you plug in x, you get out y. So your ordered pair is 3, 7. This is your x, this is your y. All right, so before we do another one, questions?
Yeah, so you said that they're always going to give us the numbers?
Yes, for the problems you'll get in this section, they'll give you the function and the number.
Okay.
And they most definitely have to give you this function because other than that, you wouldn't have anything to plug it into.
So it'll be just like that. It'll say either fx or y equals 2x plus 1, and that's the equation that we're using. Like if that's different, say if it's 7x plus 1, that would be the equation that we're using for that problem, and then we just use this. What do we use to solve it? Like, is there a...
Well, that's it. So they'll give you, like in this one right here, they'll give you the function and then give you f of 2 and tell you it's a bit, and that's all that's saying is take 2 and plug it into the equation.
How is that? What do you mean? F times 2 or f of 2 is x?
That means 2 is x and you're gonna take 2 and plug it in everywhere you see X in that function.
Okay.
Yeah. All right, so everybody good before you try that one out? He said, nope. Can I scroll up? Or you still copying? Anybody still copy? All right, 1 second, not a problem.
So
Mhm,
on the purple example problem,
mhm.
what we're doing is we're finding an ordered pair.
That's what you can pull from it. You would go here and they may ask you what is the order pair you would get from this. And then it would be 3, 7 because X was 3. That's what you plugged in and you got out 7.
And fx equals y.
Yes.
Okay.
Mhm.
All right.
All right. So let me see. Hold on 1 second. Let me see. I'm gonna go to another page and do another one, but we can do, y'all not gonna see one like this. So don't copy B. Now I'll go to another page, do some more examples, but at least we can do A. So here we have f of x is equal to x squared plus 3x plus 5. And we just, like I said, we're gonna look at just A, f of 2. And so like I mentioned before, all that means is that you're gonna take 2, plug it in where you see x into that function. So that's what I did right here. So 2 squared is 4, 3 times 2 is 6. 4, 2, and 5, add them together, gives you 15. And so they ask you the ordered pair would be 2, 15.
Now, after we do all of this, are they
Mhm.
gonna ask us to graph this?
No.
No, this
Mm-mm.
is it.
Yeah.
Okay, that's good.
All right, can we try it again? Anybody still copying? All right, cool. Let me go back to 130. Should have been somewhere here. This is my equations. Nope, nope, nope. Ah, well, I'll just make some up. Um, I'll leave it like that.
What are them letters? Is that a G?
Yes. Yes. So all I'm saying is, this is the way, when you see this notation, I can't call all of them f of x if I'm giving you different functions. So this is just function notation. In other words, this is f of x right here. This is g of x, and then this will be h of x. I'm just giving you 3 different functions, but I can't call them all f of x. You see what I mean?
You just threw curveballs though, man. What?
Oh man, you can hit.
Where
Say
did
again.
that come from? I don't follow.
Well, you know how we can use X as a variable,
Yeah,
and you know how you can use Y to represent another variable,
yeah.
or if you want it, you can use A or C.
Uh-huh.
This is the same thing. So I'm using f of X to label this function. G of X tells me that I'm using this function. And then H of X will tell me that I'm using this other function that I'm about to make up.
Oh, in different problems.
Yeah.
Okay. I thought it was all variables of the same problem. I was like, man, I'm just, I give up. I quit.
So let me see what I want to do for this next one. Mm, all right, so here I gave you three functions. F of X is equal to 7X minus 5. G of X is equal to X squared plus 8. H of X is equal to 1 minus 20X. So going back to what your classmate alluded to, these are three separate functions. All right, they just labeled differently so that we'll know what they're assigned differently, so we know what we're talking about when we mention it. So when I look at this first one and I want to find f of X, I'm not going to these bottom two right here because I'm just looking to the F function. And that just means I'm going to plug one in where I see X in the F function. So that'll be 7 minus 5, which is 2. Order pair here.
2, 2.
1, 2.
Whoa. Oh yeah, that's because the F is 1. All right.
Mhm.
I put 2, 2. I don't even know what I was doing. And the F is 1. So would it be 1, 2, or would it be 2, 1?
1, 2, because the one you plug in is always X. The one you get out is always Y. So we plugged in X and we got out Y. We plugged in 1 and got out 2.
So X is given.
Mhm. All right. So then for the next one, G of 3. So that means I go to the G function and plug in 3 for X. And also make sure you pay attention to the directions. They'll let you know if they just want the number 2 or if they want the order pair. I'm just giving you both so you'll know, so you're equipped. But it may not ask for both, or they may not, it probably will only ask for one. Just make sure you plug in which one they're looking for. So 3 squared is 3 times 3, which is 9. 9 plus 8 is 17. So order pair here, 317. Last one, H of 0. It's 1 minus 20 times 0. 20 times 0 is 0. That'll be 1. So that order pair would be 0, 1. Questions? Any questions? All right. I think that's it for that section. Vertical line test. All right. So questions on that before we go to the next thing? All right, so systems of linear equations. I think they only talk about 2 solutions. Just wanna make sure. Yep. All right, so let's look at this last section out of chapter 3, systems of linear equations. So next class, so that's systems. I said chapter 3. That should be 4.5 for you guys, not 3. Sorry about that. So it's chapter 4, 3, 7. Got one. You mean tell me I only have 2 more chapters left? I need to add some more work to this. I saw Mr. Tucker face.
Yeah, no, you don't. You know, you don't. We're good.
So yeah, this is 4.5, not 3.5 for you guys. Oh, I gotta keep, reminding myself we changed books. So we're looking at systems of linear equations. So we have x plus 5 equal to 6, x minus, I say x plus 5, x plus y equal to 6, x minus y equal to 2. So this is a light example of a system of linear equations. And the solution that we find for this system has to work for both equations. So in other words, what's not an answer, let's say if we have the ordered pair 5 and 1. Excuse me. So you know the first value is x, second value is y. Well, that works here because 5 plus 1 is 6, but it does not work here because 5 minus 1 is not 2. So we're talking about the ordered pair that works for both equations. So that's what we're looking for. All right.
Oh, that's easy.
Okay, genius.
Yeah, just kidding.
Really good. Scrolling up.
Where do we get the order pair from?
No, I was just saying for an example. I was just pulling that out as an example of why this doesn't work. It does work here. Let me see. See, it checks off here because 5 plus 1 is 6, but it does not work here because 5 minus 1 is not 2. So the ordered pair that will work for both equations is the solution that we're looking for. So if you see down here, we have 4 and 2. 4 plus 2 is 6 and 4 minus 2 is 2. So that one works for both. And so that's what we're looking for. That's what is considered a solution for these systems. And of course, we have methods. You're not going to have to go around guessing, trying to figure out what order pair works for what. So we're going to get into the solution methods in a second. Solving methods. All right, scrolling up a little. All right, so there are 3 methods: graphing, substitution, and addition. Doesn't matter which method you use, you still get the same answer, still get the same result. So what would dictate which one you use basically would be on preference. Maybe it's preference of what you see. Now, from what I saw in the previous book, you guys can let me know, this book does not focus on the addition method. So the only 2 methods we're going to talk about are the graphing and substitution. Now, they mentioned the addition method. Maybe I missed a problem or something like that. Let me know. Like I said, we did switch books, so maybe they incorporated a problem that I didn't see. If you want to, we have to talk about addition method and let me know. But right now, we're just going to stick with the first 2, which is graphing and substitution. So along with three solutions, there are three possible scenarios for your answers. I said three solutions, three methods. There are three possible scenarios for your answer. It's possible you can get one solution and you would have an order pair. You wouldn't write one solution. You actually write what that order pair is. So I know sometimes people have written one solution. I'm just like, no, what is that solution? So when you come down, like we had the answer of 4-2, you would give the answer 4-2. Now with the other two, looking at the second scenario, you can come down and have no solution. And then it's possible to have infinitely many solutions. So we'll show you how that works in a second. But those are your three possible outcomes. One solution, no solution, or infinitely many outcomes. But I think I normally put outcomes. I don't know why I put scenarios. That's all good. All right, scroll up.
How can if we're trying to find how can a scenario have many solutions if like what do you mean?
If it ends up being the same equation, remember we have two different equations here. If I simplify this and then simplify this, now these two couldn't be simplified. Remember I told you this was a light example. Let's say if I simplify both of my equations and they ended up being the same equation, then that means they would have infinitely many solutions.
Okay.
Yeah. So let's look at the first method, solving by graphing. So you're going to graph each equation on the same plane, and then where they intersect, that will be the solution.
What do you mean when you say on the same plane?
The same graph.
Oh,
Yep, same graph. You're gonna intersect on the same graph. I mean, not intersect, but be graphed on the same, same graph. So when we go back, talking about our scenarios, scenario one, remember that was one solution. So we grab both of those lines on the same graph and you see they intersect. That will be our solution.
what is that? Scenario one?
Yep, going back here to what we had here, scenario one. So scenario one is one solution. So this is the graphical representation of one solution. As you grab both of those lines, they're going to intersect at one point. And whatever that point is. So in other words, when we look at those other two lines, when we found the solution to be 4 and 2. So they should intersect at 4, 2. Scenario 2, if you have parallel lines, that means they'll never cross. And if when it cross, you have a solution. If they never cross, that means no solution. Am I done with the first? And then the third scenario, if they end up being the same line or same equation, you have infinitely many solutions. All right, are we ready to scroll up? Still right.
Still writing real quick.
Okay, not a problem. Make sure everybody watching me.
All right, I'm good.
All right. All right, so we're gonna look at that first one. X plus y equal to 6, x minus y equal to 2. So remember, we already know the answer is 4, 2 as an order pair. But we're gonna graph both of these lines on the same plane. And if we graph them on the same plane, that means they should intersect at 4, 2. Now, how you graph is up to you. Remember, we have 3 different ways that we can graph. You can either create the XY chart, use your intercepts, or you can use your slope method. It doesn't matter which way. This first one, I'm going to do XY chart. If I'm not mistaken, the second one I did using the slopes. Yeah. So, I'm just going to do different ways so we can just, evaluate and be able to make a decision on what we want to do moving forward. So if I decide to graph using the XY chart, I'm going to go ahead and either way, I'm going to call the first equation I'm looking at equation 1, second one equation 2 for labeling purposes. So let's look at equation 1. We have x plus y equal to 6. Once again, I decide I'm going to use the XY chart. And remember, you choose your x values. When you're doing this method, you choose your x values. So I chose -1, 0, and 1. I went ahead and just solved my equation for y. With all of these, the way I think it's best to deal with graphing is to solve your equation for y. It'll help you out with calculation, and it'll help you out when you talk about your slope method anyway. So I solved my equation for y by subtracting x from both sides, and now I have y equal to -x plus 6. From there, I plug in these values for x to find the corresponding y. So I plug in -1. -1 times -1, negative times -1 is a +1. +1 plus 6 gives me 7. Plug in 0. We're talking about plugging it in right here. 0 plus 6 is 6. And then plug in +1 right here. And don't forget, you have a negative sitting out here. So -1 plus 6 will give me a +5. Yeah, give me a 5. So Mr. Tucker, I see you had some questions.
Just trying to follow along here. You said we already know the solution to this x plus y and x minus y is 4, 2.
The solution, right? The solution to this whole system is 4, 2, right?
So why you using ones and zeros?
Well,
and sixes?
remember, you're not going to know the solution. You're not going to know that. You're just going to get this problem and they're going to tell you solve by graphing. So right now we're going through the process. And if we're correct, it should match up at 4, 2. See me? So we're going through the process.
Okay.
Yeah. So normally you wouldn't know the solution already.
Okay.
Yeah.
All right. So I got it right. Shit.
So yeah. So while we're getting caught up on that. So yeah. So normally, like you said, and if I didn't make that clear, I apologize. Normally you wouldn't know the solution. We know the solution because we already evaluated this system. We already saw that 4 plus 2 gives us 6. 4 minus 2 gives us 2. So right now, what you would do is you would get this problem and they would say, find the solution. And if they say find a solution by graphing, this is what we'll do. So I'm taking my equation. I chose -1, 0, and 1 because I wanted to graph using the XY chart. And I'm going to plug in -1 into my equation and find the corresponding y value. And so I took my equation and solved it for y, subtracting x from both sides. So I can just plug in X and then get my Y value. So I took each one of these and I plugged it in for X and calculated. So before we go to equation 2 and do the same thing, questions?
Yeah, I don't know how, I'm not following where this goes. So the first, when you first started writing in purple and you got your where you chose your X values, I get that. No, to
Mhm.
that. So I get that. But so then you start your equation. You're just writing your equation from up top. X plus Y equals 6.
Mhm.
And you got to substitute your -1 in there for your X.
Mhm. Okay, you're talking about over here now. Mhm.
Yeah, you didn't do that. Where'd you do that at?
Right here. Because it was X. X is right here.
So
It's negative. It's negative X plus 6. So is the disconnect coming from here to here? Like, so I'm trying to see where I can explain it differently.
yeah, that's where I didn't know. I don't, so that's just Y equals, so you're just getting the Y by itself.
Mm-hmm. Yeah. So whenever I go to graph, I always like to have my Y by itself on one side. It just gives me more information and it's for easier calculation. So I took my equation and I solved it for Y before I started plugging in my values. So once I solved my equation for Y, then I took -1, 0, and 1 and plugged them in individually to get the corresponding Y values.
So from your XY, that's what you would graph, or is that so those are the ordered pairs, right?
Yes, these are the order pairs that we're going to grab that's going to represent that line. Yep.
Okay.
And so we're going to do that last. I'm going to get the points for this line next, and then we'll graph them both on the same plane.
And you've got a -1 in your X that you plugged in.
Mhm.
And why you got the double negatives? Where'd that come from?
Yeah, that's what I was pointing at. You have a negative right here sitting in front of X. So that's that negative. And then I plugged in,
Where'd that come from?
huh?
Where'd that
Oh,
come from?
right here. Remember your original equation was X plus Y equal to 6? And
Uh-huh.
remember I said I wanted to solve my equation for Y
So you remove X.
from one side and I took it to the other side, but I have to subtract X from both sides. In order to cancel it out over here and take it over there, you have to subtract X from both sides. So that leaves me with negative X plus 6 over here.
So if you wrote it like Y equals 6 minus X, would that be the same thing?
Yep.
And then 6 minus X, if X equals -1, all right, I get it just by saying it. All right.
Yep. All right. All right, everybody done with the black, right? Scroll up. So for those who are ready to go to the green, I did the same thing, same method that I did with the purple. I took my equation, which was X minus Y equal to 2, solved it for solved it for Y, excuse me. And so I added Y to both sides and then subtracted 2. That's Y equal to X minus 2. Because I wanted to get Y by itself, not negative Y.
Not negative Y.
Right, right. See, if I had just took I had my eraser still on. If I had took the X over, then that would left me with negative Y equal to 2 minus X. But I still had to get a negative over. So instead of, messing with that, I just added Y to both sides.
Would it matter if you did, like, because all the negative verb or all of the negative, whatever the letter is called in math,
Mhm.
If it's negative, you just switch the other, whatever your answer is, from negative to positive. If it's right.
Yeah, there are always multiple ways of doing stuff. Yeah, you could have did the other way. Mhm.
Man, I do some stuff the other way and it goes wrong. Ain't no, I don't, man. All right. I'm still lost on the purple. The y equals -0 + 6. What's that? Where'd that come from?
Well, you plug in 0 into that same function for X. Yeah.
I'm just mix that one all together. I ain't even stop with that.
And we have to revisit this next class or whatever, it's fine. It's not a big deal. Just need to know what you guys need. So let me know, we'll do it.
Yeah, I think that would be good.
All right. Let me see. Oh, Tucky's still on purple? Okay. Now you muted though, if you were really saying something to me.
No, I was just saying I quit purple. I want to even mess.
But this is what we're gonna do. Since we started this problem, we're gonna finish this problem, but then we'll pause right here and then come back to this section next class. So. All right, so that's the end of the green. Here go my points for green. So I plug in -1 for X. So -1 - 2 gives me -3. Plug in 0 for X. 0 - 2 is -2. And then plug in 1. 1 - 2 is -1. Questions. You just gonna unmute and just look at me, sir?
Man, it ain't gonna help me to ask the questions right now.
I got you. All right. So once you have your points, you can graph your 2 lines. So the first set of points, purple, we got -17, 0, 6, 1, 5. So go to the left one, up 7, 0, 6, and then to the right one, 5. So they gave me those 3 points right there. Draw your line between them. That's our purple line. And then for equation 2, we have these points. Go to the left one, down 3, 0, -2, and then to the right one, down 1, and that gives me the green line. And so remember, where they intersect is our solution. And you see that they intersect if you go to the right 4, up 2, and my tick marks were off. But yeah, so right 4 up 2 would be your solution. You guys will have MATLAB with your grid lines perfect. So of course, yours won't be off, but mine are off because I did it by hand, and you can see my spacing is off as well. So, but like I said, when you're in MATLAB, it will intersect right at the point that it's supposed to intersect at. So. All right, questions on this problem before we close out? Like I said, this is a good place to stop. We'll come back here, come back to this section next class, and do a few more with this, and then go from there. Somebody say something?
Yes, are you going to post this lecture as well? So we can
What
go back?
you want it today?
Probably, if you
Yes.
can.
Yeah, I can. I'll make that happen for you.
Thank you.
Close. This is 1:30. All right. Anything else? Anybody else? Everybody good before we close out?
Well, Mr. Tucker, I do have a question. This Sunday coming up is when we're supposed to do that test.
For one of these chapters, let's see what's going on here.
I thought you always do the review right before. I thought you do like a review right before, like any questions, but we still got to continue this next class.
Yeah, well, I normally do a review after we close out that chapter. So we closed out the chapter and then I did a review. Now, if you have questions, every day opportunity for questions. So if we come in the next class and you bring questions, I entertain them. So
Okay.
yeah, I won't. I mean, if you have questions, I'll answer them. I won't have a problem with that. So yeah, you can bring them to class and we can knock them out.
Well, thank you. That's it.
Yeah. So she brought up a great point, a great a great idea. If you guys have any questions and you want to take care of them next class, bring them. And if there, if we don't have time to go into this section, that's fine. But if we have enough questions that they need to be addressed, I'm most definitely willing to do that next class. So
we can't print, we can only print the examples from MATLAB unless we do, go through solving the equation. But like if we had a specific MATLAB question, do we need to try to print that up so that we can go through it in class? Or can I just give you the number of the question?
you can just give me the number in the section.
Okay, let's do number 30.
Say again.
Number 30, the last question.
In what section or which assignment?
For the slopes, the last class.
All right, hold on, trying to get there. So you said slopes, and you said number 30. My numbers will probably be different than yours. But this is the one you're talking about?
Yes, that's the one.
All right, so let's look at it. Since 2008, the number of analog theater screens has been on the decline in the country. The number of analog screens, Y, each year estimated by this equation, where X represents the number of years since 2008. Find the X-intercept of this equation. So take a picture so I can go to the notes. Don't have to keep going back and forth. All right, so we have this equation of Y equal to negative 6,000 X plus 30,100. And we want the X-intercept. So for your X-intercept, Y is always 0. So that's always the case. So you will plug in 0 for Y and then solve for X. All right, so subtract 3,100. And just saying this as well, because I heard some people dropping out. You can leave if you are done for the day. Since she asked this question, I'm gonna go ahead and address it. But we are done for today. Next class, we'll get into, well, I guess you guys will let me know if we'll get into the rest of chapter 3. If you have questions, I will take care of them. So outside of that, you guys have a good one, be safe, and I'm gonna finish up this question for you. Say it again now. Oh, I thought somebody said something, okay. So we got 30.
Why didn't you do the division first?
Well, normally you don't do division until you're in this position. You have your single term on one side of your equation. Because if I were to divide by 6,000, in some cases, in a lot of cases, you're going to create a fraction that you don't have to deal with initially. So now here, though, I'm going to have to take this over at some point anyway. So I'll just go ahead and take that over now. And then we can go ahead and divide by the negative 6,000. And so X is equal to, let me see how many decimal places they want. To the nearest 10th.
It's like 12 different parts to that question.
Yeah, I kept getting fractions, and now I see why I kept getting a fraction. I mean, it took like half an hour, and then I just forget it.
Yeah, so now they said round to the nearest 10th. So they didn't want the fraction. They wanted you to convert it to a decimal.
Right.
So now they did say write it as an ordered pair. So the ordered pair here is 5.0 and then 0 for your y, because remember y was 0. And then they wanted us to round this x to the nearest 10. All right. So is that first one okay before we go to the next one? Okay. So then it says, and I'll let you see it. Then it says, what does the y-intercept mean? I mean, y-intercept, what does this x-intercept mean? So now remember 0 represented for y. It means that each year, it's right here, each year can be estimated by the equation, the number of movie screens each year. That's what y represents. And then x represents the number of years since 2008. So let's see here, x-intercept means that after 2008, the number of analog increased by 0%. X-intercept means that 0.5, let me go 5 years after 2008, there should be no more analog screens. So Y once again means means your analog screens, number of analog screens. So if Y is 0 and 5 means the number of years since 2008, the x-intercept means that 5 years after 2008, there should be no analog screen. And let me see if they want that 10th place. Okay, that's good enough. And so, yeah, so that's what that means. 5 years after 2008, there should be no more analog screens.
And how did you come to that conclusion?
Well, we're looking at because you remember our x-intercept, we have 5 for x, 0 for y. So you have to go here and say, okay, what does y mean and what does x mean? So the number of analog movie screens is y. So that means 0y means no more analog movie screens if y is 0. And then x represents the number of years since 2008. Well, our 8 was 5. So that means that 5 years after 2008, there should be no more analog screens.
Are there questions like this on the test?
I gotta look. I know this was the last one on the test review. It might be the last one on the test. If so, at the most, it will be 1. So 1 problem won't stop you from making an A out of the, off that test. If you want to look at it like that.
I'm gonna have to get my 5 points from the preset.
No.
So now this next one says use part B to comment on your opinion of limitations using the equation model. Equation cannot be used to estimate the number of analog screens corresponding to x-intercept. Cannot be used to estimate which negative and estimate cannot be used to estimate the number of analog screens after the year corresponding to the x-intercept. I think it's that one. Yeah. Okay. So basically here, the equation cannot be used to estimate the number of analog movie screens after the year corresponding to the y-intercept. Because remember the y-intercept, so after 5 years, it says that there will be 0 analog screens. So after the y-intercept, that means you're going to start getting negative numbers. So that's why it says the equation cannot be used past the y-intercept. because you'll get zero. After zero is nothing but negative. So there's no such thing as a
Okay.
negative, number of analog screens. You know.
Okay.
So, so that's why you can't use it past that Y
Okay.
intercept. Was that a question?
No, I said, thank you. That part now it makes more sense.
Okay, cool. I'm glad.
Thank you.
All right, no problem. And I'll work on getting this video up for you before the day is out, probably within the next hour.
Okay. All right. Thank you so much. I appreciate it.
All right,
Now,
not a
getting
problem.
back to test, I did take the test already,
Okay.
but I think probably I had so much going on in my head because I did homework and then I did the test and
Mhm.
it got all screwed up. I mean, I had fractions and percentages and everything going everywhere. To numbers, but as long as I read the test before third, I'm okay. Correct? And you don't even have to look at the scores, right? You just say they just show you the high score, or do you see both scores?
I see both, but I only record the highest. I can see it's like this. I can go looking for the second one if I want it, but the highest is the one that pops up.
Oh, good. You don't want to see the first score. You don't want to see that.
Right. I feel you. And I think you had emailed me something along those lines as well.
I did.
About you're gonna take the second one again. So yeah, I saw it. You good to go.
Yeah. Okay. Yeah, I did. This is if my patients had to depend on this, they probably would die. I would have killed by the time I figured all this out.
Right.
Okay. All right. Thank you so much.
All right, not a problem. You have a good one.
Thank you. You too.
All right. Anything else? Anybody else before we close out? Very good.
You mean, because I got stuff, but it might not be for the whole class.
Oh, okay. Well, yeah, we said we need to set up a time to meet anyway.
Yeah.
So, well, shoot me that email so we can match up our schedules.
Okay.
Now, I got them office hours already set. If you want to come to those, that's just set.
What is that? That's just you sitting there waiting on somebody to pop in and ask you questions?
Yeah.
All right. Yeah. So you sent that in the email already?
Yeah.
All right. So I'll check that and I'll pop in on your next available date.
Okay. Sounds good.
All right. Appreciate you, man. Thank you.
All right, man. Have a good one.
Do the same.